And this is a project being done by Internet Research Lab at UCLA. Okay. So today I'm going to talk 4 parts. First is an overview of NDN-LITE recording.
So after the overview, I'm going to talk about some code-based stuff, and the package is designed for different platforms. And after that, I'm going to show the basic building blocks for applications with some examples, and finally the future work. So here comes the very first question: why we need NDN-LITE? So here is the answer. NDN-LITE is designed to run over resource-constrained devices, and it is designed to be a framework for the system. So here I highlight the system, this word, because we are not building a network layer. Instead, we are providing a IoT system framework. For example, we provide the modules for security bootstrapping, for service discovery and access control, and some others. And also, this is a platform designed for developers, so that the developers can use our platform, the framework, to develop their own applications. So that's why we need NDN-LITE. And because of the different goals, we have several principles to follow. So first, as I mentioned, it's a system framework. And also, we wanted to work with different platforms. Ideally, that support raw language C can use our NDN-LITE framework. And also, we want to have the minimum memory overhead and zero dynamic memory allocation. This is for the embedded platforms with minimal memory and for better efficiency. Also, to fit into some IoT platforms that only support single thread and single process, we actually make the decision to run the application and NDN folder together in one process. So this is one big difference from the existing one. These principles actually distinguish our work from the existing ones. So first, we explain the relation to NFV and NDN-CXX. So we see that NDN-LITE is different because it's designed to be a system framework instead of network layer and forwarder solely. And also, we have a lightweight forwarder which has a smaller footprint, which has reduced overhead, which also has the reduced functionalities. Some functions like the forwarding hand and the read management is not in the NDN-LITE. And also, we want to have we have the lightweight encoding and decoding compared with like NDN-CXX. This actually reduces the memory overhead for application development. We also have some simple comparison with NDN-ROUTE and the NDN-LITE. Actually, in fact, as Lisha mentioned, so NDN-LITE's original goal is to renew and improve NDN-ROUTE code base, but later we decided to have a clean slate development for IoT framework that can do cross-platform. The big difference is still NDN-LITE is to be an IoT system framework with all those high-level modules instead of just the package and folder. And NDN-LITE is designed not only for the route system, but also it's a framework that can do all the IoT platforms that support C. And compared with NDN-ROUTE, we don't support multi-process design. This is very different from the previous NDN-ROUTE, which separates the forwarder and the application into 2 different processes. And compared with NDN-LITE, again, it's a system framework. Here's a report of where we are now, and now developers can use NDN-LITE, the framework, to develop NDN applications over IoT platforms. But we see that NDN-LITE is still under active development, and there's still some way to go. So first, the high-level support has not been fully realized. So that's why if some developers already try our stuff, already tried NDN-LITE, the developers still need to configure the face and work with the interface packets directly. And this will later be removed hidden from the developers. And now we have NDN-LITE support NRF52 boards and also the Raspberry Pis. But ideally, it can be adapted to any platform that supports C. some system high-level modules are actually missing now. For now, we don't have the access control part. We don't have the pop sub part. I mean, we have a access control running, but it's old version, and we will remove it soon. So this colorful, as you can see, these colorful boxes represent different modules of NDN-LITE framework. And let's go through them one by one. So first, the application support component. That's the green box. And as you can see, it has the bootstrapping, which helps the application to obtain the identity certificate and install the trust anchor of the home IoT system. So we use the protocol called the security sign-on SSP over NDN protocol, and it is actually a published paper on IEEE Communication magazine, and I put the link here so later people can download the slides and have a detailed look of the protocol. And the second part, service discoveries. This is for the applications to discover available services around the device and also advertise their own services to others. And the same, we also have the protocol. We have some slides which is presented during the NDN-CON 2019 at least. And the PubSub and access control, as I mentioned, is still under work. We are still working on the design and implementation of these two parts. But ideally, PubSub is to let the applications to subscribe to their interested services and also publish their own content to their own prefixes, that's their services. And the access control is to protect the data confidentiality by encryption, and also to grant the access rights to authorize the identities. And the last bullet is the SCHEMATIZED trust. So this is to ensure that only authorized identities can send clients to IoT devices to execute their own commands. So then is the orange box. That's the network part. And this part actually provides abstraction of the NDN network layer. So it includes the folder, which is in the same process as the application. And in our NDN-LITE folder, we don't have memory copy in the packet processing. That improves our performance. But however, the content store is currently not supported. And besides folder, we also have the NDN packet decoding part, also the face. So notice the face here. It's not a real network interface, but it's an abstract face for network interface. So here we define the format of a face, and the real face will be implemented by some adaptation, which is platform dependent. I will talk more about this part later. Okay, so next part is the purple box. This actually provides a set of utilities for the library development and also the application development. And it includes the key storage, which is the in-memory storage to keep devices certificates, trust anchor, and also keys. And also the clock. This is to provide the time support, especially used for like network packet timeout and the event queues. The next part is fragmentation. So this is to fragment and assemble NDN packets into or from the batch chunks to feed the different MTUs of different link layer protocols. And next part is the crypto support. So this is to support crypto operations used in NDN security and also application security. This includes the digest module, the SHA-2 module, the encryption module, which is AES, and we also have the ECC module, HMAC module, and also RNG module for the random number generation. And the last component is message queue. So this is actually an event queue that keeps events from both NDN folder and also the application. And this event queue will be run by the program main loop. Up to this point, what I introduced before, they actually is the NDN-LITE core library, and this part is not in the core library, but it's in the package. So this part is for the adaptation component. And this part is platform dependent. To be more specific, it provides the adaptation to its own platform. We have the face adaptation. This is to extend the abstract face to a real link layer interface, like the IEEE 802.15.4, a BLE, and some other protocols. We also have the clock adaptation. So this is to provide the realization of the time interfaces defined in the time module. And we also have the crypto adaptation. So this adaptation is to serve a better security using the locally supported security modules. For example, you can use the platform's hardware TPM or hardware RNG to have the strongest security. And also you can use the hardware, for example, the hardware ECC module to achieve a higher efficiency. And this is actually optional. So if there's no crypto adaptation, NDN-LITE has its own default software realization of the crypto parts. So now let's have a quick look of how IoT devices is bootstrapped, how it can do service discovery, and how to do access control in such an IoT system over NDN-LITE framework. So here shows a very simple example of a smart home network, which they have a unique prefix to be /myhome. And this is an example, but in real world settings, it should be a unique name. And all the names are actually semantically meaningful. And again, to mitigate eavesdrop for privacy, for security, the wire format of the names can use some obscure coding to hide the details. And in this talk, I'm going to use the human readable names for illustration. And as you can see here, we have a controller and a temperature sensor and also some other sensors. The first part is bootstrapping. Assuming now we have a new device that's AC, and we want to bootstrap this AC into your own IoT system. So instead of depending on the remote cloud to authenticate your new device, we totally localize this process into your own local system. So basically, your home IoT controller will bootstrap the AC and achieve two goals. First is to let the AC install the home IoT trust anchor. So this is a certificate. The second is to let the AC to obtain its own identity certificate. So with this identity certificate, other devices can recognize this AC as a new home member. After the AC got bootstrapped, it can use the service discovery protocol to discover services around it. For example, the AC wants to use the temperature sensor service to get to know the current temperature of the home. In our service discovery protocol, we simply let the AC to carry the services, and this through the broadcast media of the various home IoT network. And whoever has the information can send back the data packet. And the air conditioner, the carrier, can validate this packet using its signature, which will eventually goes back to the home trust anchor, and also to use the trust schema to verify this packet. So trust schema ensures that only a valid identity, authorized identity, can make this data packet. So next is the access control. So considering the service information itself could be sensitive, like you may not want others to know that you have an electronic door lock at home. So we actually apply the access control protocol to the service discovery process to protect the service information. To be more specific, the content will be encrypted, and only a valid home device can have access to the content, which means to obtain the decryption key to the content and decrypt the content to see the answer. And next, I'm gonna talk about the code base and packages for different platforms. So let's first take a look of how NDN-LITE code library is like. And here you can see a screenshot taken from the GitHub repository page, and this is how the code base is like. Under the root directory, we have a slash. We have an app support folder. So this folder keeps the application support modules, as I mentioned, like the service discovery and bootstrapping. But we also have the encode folder, base folder, folder for the network support. This is for the encoding and face and forward. And we also have the security folder and the util folder for the utilities. NDN-LITE is the common functionalities across platforms, and the adaptation actually provides some concrete realization of some parts of the framework. So a complete package actually contains the NDN-LITE plus the adaptations. So this structure actually allows NDN-LITE framework to work with different platforms. And our principle is like the most common parts goes to the NDN-LITE collaborate, and the least platform-dependent realization actually goes to the adaptation part. So here I show an example of how a package is like. So I'm using the NORDIC package as an example. So it contains, as you can see, 3 folders in its root directory. First part is the adaptation. So this contains the adaptations, like the security adaptation, the phase adaptation to the IEEE 8254 phase, to the Bluetooth low energy, and also the adaptation to use the local time. And the second folder is NDN-LITE. This is the NDN-LITE collaborator. And also we have a folder called the examples. This contains the real applications, which is over the package, using the package. Yeah, so for now we have adaptations to mainly to 2 platforms. One is NORDIC, one is POSIX. And here shows the NORDIC SDK. Here shows the NORDIC NDN-LITE package. And as you can see, we have the base adaptation to BLE and 80254. But we also have the crypto adaptation to use local RNG and the SHA-2 support. And then here's the package for the POSIX, like the Raspberry Pi. We have the phase adaptation to use the UTT phase and also the Unix socket phase. And we also have the crypto adaptation to use the local RNG, pseudo-random number generation. Besides that 2 packages, we also have a NDN-LITE for route. But for now, we only have the unit test available. And there's no adaptation. And a real package will soon be built after we finish the main framework. So to get started and use NDN-LITE framework, the first question to ask is what platform you are using. So if you are using like an RF course, then you can use the NORDIC package. If you are using like Raspberry Pi, then just use the POSIX package. If you have some other boards, I know there's a lot of them, then you may need some custom adaptation layer to adapt NDN-LITE to that platform. So we have a lot of documentation to help you to adapt NDN-LITE to your own platform. After you select the package, then you can develop your applications with NDN-LITE collaborate and the package and the adaptation. Here's the screenshot taken from the NORDIC package repository on GitHub. It shows how to get started to use the whole things. Now, so similarly, we have a README for the POSIX package. Finally, we got to the third part, which is the basic building blocks for applications. So better illustrate how NDN-LITE works, I'm gonna use some extremely simple examples to show some real code. So I will have 2 programs here. A very simple program to listen to input packets and reply a data packet back, so produce it. And another program to send an input packets and get a data packet back to the consumer. So these are some examples just for illustration. And in a real example, security must be considered. Like you have to use the secure bootstrapping to bootstrap yourself into the system so that you can get all the keys and the certificates and then start your program. As I mentioned, now developers somehow need to manually do some phase operations and packet encoding, but in later version, we're gonna simplify this logic by some high-level APIs. So here's the logic for these two examples. The producer first is to init the program, to init the NDN-LITE framework. And also, this part actually includes the initialization of the folder. And after that, we create a phase. So this phase is actually an external network phase, like Bluetooth. And then we have a function, then we write a function to handle interest packets. So this is actually an on-interest packet callback. And then we register this prefix, we register this callback with a prefix into the folder, and then we start the program, which means we start the main loop of the program. And regarding the consumer, similarly, we have the init part, we have the phase creation part, and differently, we have a function to handle a reply data packet when after you send out interest. So this is on data callback. And next, in the main function, we can express the interest packet and register this callback with this interest, and then start the loop to process the packets. Okay, so first, initialization. So we can create an example.c file under the example folder in any package project, like the POSIX project or the NORDIC project. To start, we have a main function here in the example.c, and in the first line, we call some initialization functions to start NDN-LITE. And as you can see here, I actually put 4 lines here. So these 4 lines will start 4 parts of NDN-LITE. So developers now need to explicitly call these 4 functions at the moment, but these functions will later be simplified using some high-level things or be automatically called by NDN-LITE framework. So after initialization, we can create a phase. So we create a phase to enable NDN-LITE to get access to a network interface, like the Bluetooth. And we can use the function provided by the phase adaptation in the package to create such a phase. So for example, if you check the code here, we're actually using the NDN BLE phase construct this function to create the BLE phase. And if you check the detail, like how this NDN BLE phase is like, you can see it contains a struct called the NDN phase INTF interface type. So this struct is how the NDN-LITE library recognizes or use a phase regardless of the detail realization. And with the phase, as I mentioned, so this phase is actually an external network phase, and this is one difference compared with NDN.CXX. So in NDN.CXX, if you are writing an application, then the phase that you create is actually an internal phase to talk to the local NFD daemon. And here in NDN-LITE, since we put the application and the folder into the same process, there's no need for any internal phases. So the phase here is a real network interface. After we create a phase, we can create a name prefix, which will be used for the prefix registration. And we can simply call an NDN name from string to create a name. Here we create a name like /example. So with the phase, with the prefix, then we can register the prefix and get ready for the interest packets. But before that, we still need an on-interest callback function to handle the interest packets in the future. So this function will parse the interest packets and reply a data packet back. So if we check the code, in the first 2 lines of the function body, we actually parse the interest packets with this NDN interest from block. So this will parse the TLA word format paths into an NDN packet. And then we create a data packet using the TLA make data function to create a very simple data packet whose content is I am a data packet and send it back. We use NDN forwarder put data to put this data back to the interest. After we have a ready to use on-interest function, then in the main function we can register the prefix and send the callback. So we can use the NDN forwarder register name prefix, and we put the name prefix here, also the on-interest callback here, so that we register the callback to the prefix, and then finally the final step, that is to run your NDN producer program. So you should start the program by calling the NDN forwarder process function in a main loop. So this NDN forwarder process function actually it will process the NDNICE main event queue to run the program. And if anything bad happens, like your like, for example, your device crashed, be sure to have an NDN phase destroyed to release the phase. So that's an example of how a producer is like. And to write a very simple consumer, there are only several little differences here. First, we don't need the on-interest callback. Instead, we need the on-data callback. So this on-data callback is to parse the incoming data packets. So if you check the example code here, it will first do a signature verification and the decoding, decode the bytes into a data packet. And if the signature verification or decoding is wrong, you just, in the example code, we just print decoding failed. And another difference is that in the main function, we don't need to register the prefix. Instead, we add a route. So we use as shown in the first line in the example code, there's the NDN forwarder add route by name. So this is to actually add a route into the folder that if you receive an interest under this prefix, go to this phase to express it out. And in the main function, we also need to send an interest to fetch the data. And to do that, we first use the NDN interest from name to construct an interest packet. And then we express this interest out by using the NDN forwarder express interest. And that's how that is how consumer is like. And here, I'm gonna. So the previous two examples are very simple examples, and do not really use the high-level modules provided in the NDN-LITE framework. And here I'm gonna show some examples of using NDN-LITE's high-level functions. Okay. The first example is to use the bootstrapping protocol. So we provide one function call, which is called NDN security bootstrapping. So with this function call, this will automatically find the controller who listens to a specific prefix and bootstrap with this controller. And after that, this function will also automatically add the route, the whole prefix to the forwarder, and also at the same time to keep the trust anchor and also its own certificate into the local key storage. So an example is like after you initialize the NON-UITE, after you create a phase, you can simply pass the phase and some shared secret, for example, the shared secret that is corresponding to your device's QR code into this function. And to do the bootstrapping, this will achieve the two goals as we mentioned. Second part, we also show the service discovery protocol. Here we have two function calls. One is start advertise self certificates. So this will let the device to answer others' query that I have these services available. And we also have a function to start listen to others' query. And this function will actually be called at the end of bootstrapping part. So the developers will need to call them manually. And here is an example. So after you initialize the NDN-LITE framework, after you create a phase, you can have an NDN-SD init to init the state and insert your own services into the in-memory state. for the service discovery. So here in the example code, we have the device to have two types of services. One is LED service, one is the temperature service. And by calling these two functions, when some other device query these two devices, when they query these two services, your device gonna reply the query and advise yourself to them. Next part is about the schematized trust. So this is to verify the packet name and key name is in certain pattern. So we also provide a function call, which is NDN schema verify data name, key name. So a little bit longer, but it's one function. And the example is like, first you need to have the trust schema. So the trust schema is like the relationship between the packet name and the key name. So assuming an example like you only want the home controller to turn on the LED light, then you have a packet name to be home, LED, something in the middle, and on. So this is a name pattern of a command interest to turn on LED light. And then you define the key name of such an interest to be home controller something. It could be home controller address, home controller ball, which are the controllers actually. So you define the name pattern of a home controller's key. And then you load these two patterns into a trust schema rule using the function called NDN trust schema rule from strings, where you pass these two strings into it. And when you receive a packet, like let's say when you receive an interest packet with a signature, then you can check this interest packet to using the function as we mentioned, NDN trust schema verify data name, key name pair. To verify it, and then it will returns the boolean to indicate whether the packet is valid or not. The last part is about the future work of NDN-LITE framework. As I mentioned, access control and the pub sub part is not done yet. So we are exploring the electric version of NAC into the NDN-LITE. And for the pub sub, we noticed there are a bunch of work published on this topic. And we still don't have a concrete design of how to do this pub stuff. But we are now having active discussion on this. And in the future, we want to have details of the system security. That is, we want to have all the security check, like the signature verification, like the schematized trust verification. We want to have them all from the developers, so that developers don't need to be security experts. They can only care about their own functionalities and services. And another future work is to, as I mentioned, simplify the current logic. We want to have all the packet construction, encoding, decoding part. We want to have the phase operations, prefix operations from the developers. So ideally, IoT developers write their program like in this way. So they just need to realize their IoT services and functionalities. For example, how to do door lock, how to censor the temperature, and some other things like what service they are interested to listen, and which services, what content they want to publish to their own prefix. We want to make developers life easier, so they can merely take care of their own stuff. Another future work is to adapt NDN-LITE to more platforms, like the Route OS platform, Arduino platform, and having more phase adaptations.